Good day. We've got CEO Craig Nicol of Graphene Manufacturing Group joining us. GMG is a graphene technology company producing low-cost, high-purity graphene and graphene-based energy savings, fluid and lubricant, and battery technologies. It's Tuesday, July the 11th, and I'm Martin Gago with Market Radius Research. Please remember this is neither recommendation or investment advice. We're here to learn about the company. Craig, thank you very much for joining us. It's early morning for you in Australia. We first met several years ago before you actually went public, and the world of graphene has grown immensely since then, although we're still at very much the early innings of adoption, and the opportunities are immense and still very greenfield. So thank you for joining us. And why don't you first walk us through a quick presentation, and then we can take questions from the audience. So thanks a lot for joining us.
Thanks, Martin, and good morning and good evening, everybody. So Graphene Manufacturing Group is a 7-year-old Australian public company that's listed on the TSX.V. Got the usual disclaimer there for forward-looking statements for high-growth companies such as ourselves. What Graphene Manufacturing Group is a disruptive clean tech company. We have our own graphene production process we develop ourselves, then we blend that graphene, and then we go and make products from that graphene, including a graphene battery. We're in the market selling 2 of those, and we're developing our battery as we speak. The leadership is formed largely ex-Shell, including myself, who have an energy markets knowledge background, which is why we're very much focused on the energy transition in our business with our graphene and our products. We have our own proprietary process and IP, and that has enabled us to be able to create a really unique type of graphene, and they're either protected by trade secret, the IP, or they're protected through patents or patent pending, and how we have licensed them from, say, University of Queensland for our battery. Our business actually exists with a bit of a supply chain overview like this, which is showing where we take the natural gas, we use our own process to create the graphene, and then also we have hydrogen as the byproduct, and then we go and put that into these 3 products: the thermal XR, which we'll talk about, the G lubricant, and the graphene aluminium ion battery, and then we sell those products. We don't actually sell the graphene. The product portfolio market consists for us in terms of focus is our thermal XR, which we believe is about a $28 billion opportunity for our heat exchange coating systems. And we'll talk about that shortly and what that means. We've got a G lubricant additive, which is already in the market. And that is a well-known market, a $15 billion market. And it's been there for hundreds of years, and at least 100 years known. And then it will be there for another 100 years. We still need lubricants even with the energy transition. And then the graphene aluminium ion battery, which is a next generation battery, which we'll talk about in detail. That one's obviously almost an unmet supply, unmet demand, which will probably be an unmet demand for many, many decades, given the amount of batteries we need in the world and how many batteries can be produced with the additional mining and battery processing coming in. But that's right now seen at about 100 billion, likely to be a trillion, I'm sure, by the end of the decade. Our business objectives are to produce graphene and improve scale graphene production. We have a modular system which enables us to switch on capacity quick, low cost, and we have that high quality, which is all the important thing for graphene. We're looking to build the revenue from energy saving products, so accelerating our sales as much as possible through distributors and also large B2B industrial clients. Developing our next generation battery, which we have the support of with University of Queensland and other companies like, say, Bosch, who are helping us with our manufacturing of the battery. And then developing the supply chain partners, because everything in this space, as we start to scale, is all about collaboration. And we need big partners who've done this before and who can do it with us and can help us get the scale as fast as we can. Now, where are we going compared to what our objectives are? Expansion of our graphene plants well underway and enabling increased production, but also it is a fully signed off project from an engineering point of view, so enabling us to pretty much put that plant anywhere after that in the world. We have a sales revenue that is definitely building. We've had a number of distributors signed on in Asia, plus also direct B2B opportunities are increasing. And we've got other distributors, larger distributors that are coming on as we, as we work through the next short period of time as well. Developing of our next generation battery, we have an operational battery development center, which is we built ourselves. We have a battery technical progress, which is confirming that going from coin cell to pouch cell is definitely working well. And we've just announced our first major partner with Rio Tinto as a mining industry segment partner to help to buy and once it's developed, and then use our battery in their large trucks, their large mining trucks, and also in other applications where it meets the demand. Then with our partners, we're obviously still working with the University of Queensland on various things, including validating our technical heat transfer work. We've just aligned and structured our business around bringing all the technical work under one person, which is Chief Operating Officer. That means all the graphene production and all of the battery development and coating development gets all coordinated, and all the learning can be kept in one team. And this is so we can keep and look to accelerate for development for our main customer, Rio Tinto. We've also just recently got our regulatory approvals for producing and selling our product in Australia. All nanomaterial need to be approved in Australia, like anywhere else in the world. USA is in progress, but most of the countries around the world are also okay as well. So let's go into some detail. The graphene expansion project update. Project is going well. We're more than 50% complete. We look to complete by the end of the year, if not before. Here's an example of what it looks like, 3D modeling. Its expected cost is about $2 million. From that $2 million, we expect to make somewhere between $4 to $5 million, which shows you the good payback from our thermal XR and G lubricant. The next expansion project would be, we believe, we understand, will be lower cost and also faster. The potential for us to, with our existing site, is to potentially multiply that by about 10 times in terms of total production available from that site, although that's not optimized. So we believe we could probably do better even with more optimization. As we've also announced, we've also signed 4 Asian distributors, so South Korea, Thailand, Singapore, Indonesia, and they've been learning with us for some time. Thailand especially has been learning with us for many years, and they've already got some large customers they're working through delivering large HVAC refit or on-site install air conditioning coating with our thermal XR. But we're also been developing our other markets with thermal XR, including the LNG market. This is one LNG plant we did last year. You can see the silvery grey type pipe layout cooling system on the top, and then you can see the black coating going on the bottom photo. Anecdotal evidence from the engineers on site said it did get a significant improvement, around 15 to 20%. We haven't seen the data yet, but that's what they've said anecdotally. That is a massive amount of improvement for an LNG plant. If they have the gas, that would increase profitability significantly for that plant. Of course, that was a small micro LNG plant. How we can take that to a larger LNG plant is the next space we're in, and we're in discussions with some very large LNG producers. And let's just say it's a highly profitable opportunity, but it makes even more money for the LNG plant and pays back very, very fast, well within a year. So it's something we're pursuing very intently.
Craig,
Yes.
in the LNG market, the LNG plants, because you're compressing it into a liquid form, you've got tons of energy that's required to do that, a lot of thermal transfer as it gets, I guess, cold as you compress, anyways, so with the huge amounts of energy or the large amounts of energy required, that 15-ish% is pretty substantial, right?
Well, yeah, what it means, because LNG, that they don't actually, it's well thought that they compress, but I've come from the LNG industry and they actually liquefy. So they liquefy through refrigeration. So they're just one great big fridge. They refrigerate it to negative 161 degrees Celsius. So as a result, there's an enormous amount of energy to cool the gas. And as we can do cooling better at the same temperatures that they're trying to do than without, we're a huge opportunity for them, and they're a huge opportunity for us. And so what that means is our coating really should be technically applied to every LNG plant there is in the world, because it shouldn't be without it. We've proven that with our coating on aluminium, and we've just put in place a small LNG demo rig, just with water, not with gas, at our site in Richlands. And so we can show that our coating cools the product more than without it. Now there's something like 400 million tons of LNG capacity already built and underway. That makes the world somewhere, I think, close to $1 trillion a year. Now, when you actually compute what else is being added in, which is another 400 million ton of capacity being built right now or proposed, this market is also massive, but it's also, probably never ending as well. So it is something that just comes from the fact that we can cool faster, cool equipment faster, cool metal faster, and they're a whole project or an industry that basically based on itself on cooling.
And the technology basically works by it increases the heat conductivity of what you spray it on, and then it runs more efficiently because cooling is basically sucking the heat out of something, so it can suck the heat out faster and more efficiently.
Yeah, so we basically cover, with our coating, we basically cover the metal, and when that covers it, the graphene, which is it's the highest heat transfer material there is known to man. It's about 20 times faster than silver, which is otherwise the fastest, or the next fastest. And when we cover that, what we do is we disrupt the metal to air surface, which is the resistor that slows down metal heat transfer. And we do that through very, very thin coating. It's about 5 micron coating, and obviously our graphene type, which is very important. You can't, what we found is it's not applicable for all graphene types. And so when we put those two together, we get this effect, and we've been studying it for 4 to 5 years now. So, and we've now been able to master it, so to speak. We now know how to manage the heat, and we can actually make things hotter. We can actually make things colder, depends on where you coat them. And then it's also highly corrosive resistant and much better to clean. So there's a lot of benefits. In fact, some of our customers are just buying it straight for their corrosion resistance and the fact that they don't have to clean it much. You get about 95% reduction of water hanging on it, comes off. We've proven that as well. So the benefits are quite a long list, but most people, especially in this area, are really interested in actually being able to protect their equipment, but not actually make it worse in terms of energy. Because that's pretty typically what you do when you coat something. You make it, you slow down the heat transfer. But we've shown now, University of Queensland proven, and also third-party laboratory, where we've heated up the cooling, fastened the cooling for brand new equipment, brand new air conditioning equipment. We've definitely shown that we can move heat faster with our coating on.
And your system, it could be installed at the OEM level at the factory, but it's a retrofit as well. So if there's an existing facility, it could get sprayed on and applied relatively inexpensively, and then increase the performance of an existing facility. Yeah,
that's correct. So we're almost finished a job at a project at Elements, which is a beautiful 6-star ecological resort in New South Wales in Australia, and there's something like 200 air conditioners, and we've sprayed the actual outside of them as well as the inside of them. And there's actually a YouTube clip came out last night for the owner of that hotel, who talks about why he chose that. And it enabled him to have the heat pumps, which are directly under the pool, to be sprayed, as well as all the air conditioners under the hotels. And there was no, from what he says, there was no step back for customers, and there was no equipment to be removed. And we got we're getting the coating done. We've certainly got most of it done already. And then he's hoping for large energy savings, because he's got his power bill, so to speak, as well. So yeah, it's a real breakthrough. Previously, coatings where you had to remove the air conditioning system, and then you would go and put it into the supplier's hands, and so you'd have to get a crane and lift it out and then put it on a truck and send it to the coating company, and then they would try to break it apart and then dip it and then put it back together, dry it, dip it, put it back. So we're literally we come on site, we wash, we etch, remove the corrosion, and then we coat. And now we've done that a number of times, and that's what we're training our distributors in Asia. And obviously America, which we talked about, is in the past couple of months in the press. That's obviously next, is to bring the largest coating market through a distributor agreement, which we're close to finalizing.
On the air conditioning or the heat transfer market, right now it's all retrofit. If once it gets accepted and the thermodynamics are accepted, could you actually create additional cost savings, where when the engineers are designing the heat pumps and everything for the systems, they say, hey, it increases efficiency by 15%. So I know we make the motors or whatever 15% smaller, and then we can just sort of lightweight the entire thing to provide additional cost savings and energy savings from a design built using this.
Yeah, that's true. So we can we will get some good savings, and we've seen good savings in radiators, air conditioners. And so what you'll be able to do is at the OEM level, reduce the amount of metal involved, by a similar amount, say 15%. Well, then you would reduce it by 15%. And then, say for trucks, large trucks, their biggest fuel bill, or additional fuel bill, and cost on top of pulling the weight, is the air resistance, because they're moving through the air, at 100 kilometers an hour. And that's all around cooling the radiator. So if you can reduce the radiator size, it's a huge reduction in fuel bill. And so our product should be able to aid a reduction of the what's the bonnet size and of the rigs of the trucks, because the radiator can get smaller. So the place you can move through this is, you can just keep going into very different sectors. We keep focusing on the HVAC sector, which there will be OEMs who will jump on board, and it is a highly effective way to manage the corrosion on your condenser coil. So I challenge the air conditioning companies to come on board. That's genuinely why you replace an air conditioner, is because the condenser has corroded. So we'll be stopping a lot of the reasons why people wanting to buy a new one, which is not necessarily good for the industry if they want to keep making new ones. So that's the first thing. Then if you branch that out into things like data centers, we've successfully done a couple of data centers in Indonesia now, with between 10 and 15% energy saving, and it's an enormous market. That's generally served through the HVAC market, but there are some specialty builders that go and build the data centers. So that's another sector. Another sector that we think will come on board is our ability to spray onto solar cells, the back of solar cells. And we've seen about a 4% increase in power in a day, because you've seen a reduction of the temperature of the cell, about 20%. You'd see once we spray our TXR on the back of a solar cell. and that's all patent pending, by the way. So that's another opportunity. But the LNG space and other industrial opportunities are definitely looming large, and we have some very large companies who do world-leading work in this space who we're working with in NDAs, and that's where we will make some really big gains in terms of showing industry that we can move heat faster, and heat is generally the one thing that controls all energy transfer. And when we can work with those companies, then we're unlocking an enormous B2B relationship opportunity for us and them as well.
All right, thank you.
Yeah, so onto the battery space. So we've almost over a month now ago, we announced the Rio Tinto joint development agreement. So they're paying us $6 million over the next 2 years to develop and lead and help us get to where we could hopefully one day give them a battery for their large equipment and their large trucks and other applications if so demanded. The heavy vehicle equipment OEMs have been sought to come on board with Rio, and we're working through. We've already had a number of meetings and detailed meetings because we've been working with Rio for probably close to 2 years now in detail, because we signed an LOI before this. This is really quite a crystallization of our efforts to get to show that aluminium-ion battery, which is a new technology bringing to market, we're really the only company of any note that's kind of making this happen in this space. And when you have one of the largest companies in the world who also is an aluminium miner and processing and manufacturer, you clearly you're hitting a milestone, which we've had to reflect on. They have preferential access rights for the battery, which is fantastic for us and fantastic for them. They want a battery that is obviously safe, that gives them what the equipment requires, which is very fast charging and also fast discharging for the high power applications, and really rugged environments. And we think the aluminium-ion battery is going to get there for that. We've got to do a lot of work. We'll show you shortly on the next slide where we're at in terms of the technology readiness. But we think we've got some opportunity there to enable our aluminium-ion battery, our graphene, and put that together in a pretty simple type battery, which will then provide them with their decarbonisation outcome, or at least part of it, which of course they've committed pretty strongly. Now, why does this should touch a few nerves? Because for people around the world, we've got to have something like 10 to 20 times more mines to mine the material to make the batteries that people want to put in the cars. And companies like Rio are absolutely in the middle of this, and they need to make this happen. But they've also got to find ways of decarbonising themselves. Otherwise, you start to have a counter effect of what you're trying to achieve. And they know this, and they've led this, I think, from an industry point of view. So it is great to work with them. And so they're very much focused on decarbonising their operations. And I think they should be praised for what they're doing. And it's really great to work with them. And they've come out wanting to work with us in a way to take this technology all the way through. And I think that will enable us to make sure that the battery is going to be suited for their requirements. The other alternative was to wait, like quite a few other companies who are under NDA with us are waiting to see what comes. And typically, if you wait, you don't get what you genuinely want. You've got to put up your hand and say, I want to help. And that's what Rio is doing here, which is fantastic. So where are we at with in terms of our ability to get this to market, and to explain what a battery readiness level we're at and where it is, to get to where commercialization would be. We've made thousands of coin cells, and that's enabled us to understand, improve the science, And now what we need to do is identify the right materials that can work in a pouch. And we're now making pouch, and we'll show you shortly what that kind of pouch looks like. But we've got to get to a multi-layer pouch where the materials are scalable. And the scalable material is part of it is very important. We can't have a material that is only available in lab quantities. So we need to have scaled up materials from pretty large companies around the world. And that's what we do. So we look for material, we find it, we then typically take some time to come. It's not, overnight. It typically takes a discussion, development, and then people will send it to us. And then we'll test them and put them into the pouch to see see what it looks like. And then once we've identified that, and we then try to optimize that, or if it didn't work, we go on to the next material. When I say at work, what we're trying to do is optimize around a certain parameter, and that is around longevity, obviously, and around the ability to keep the power density, which we've got, which we can talk about again, but also getting the right energy density. That's really key. And the energy density, which is around how far you can drive in a car, whereas power density is how fast you can accelerate. So power density is good. We're 60 times faster than a lithium battery, and that's there. That's almost locked away, no matter what we do. It's the energy density is around just removing material out of a battery, and that takes time. You got to do it in the right way, and you've got to have the material available at scale to be able to do that as well. And we're lucky. We've got 40 years of lithium-ion battery material development and production around the world, and so we're largely working through all the lithium-ion battery materials that have already scaled. And there are a lot of companies out there that are willing to work on something slightly different, like ours, to make us something else to give us what we need. So what our job is to get through the pouch cell by the end of the year, or a bit early next year, which we're hoping to do for Rio. And then once we've done that, we'd aim to give them a battery pack in the following year with a small number of cells put together, so we can show that it's got proof of concept, that it can scale, and it can provide a module-like battery pack that can be put into a large truck, or eventually into almost any device that can be put with an energy battery pack. Once you go through 3, 4, then you go into 5 and 6, which is the component production process. Now, components are pretty simple in reality. There's just aluminium foil, which is just the anode, and the cathode is just our graphene. It's about 95% graphene. There's a small amount of binder, and we're currently using water as the solvent. So we're trying to make this as green as possible to get there in the end, because there's a lot of solvent normally used, hydrocarbon solvent used to make batteries, to make lithium batteries. So that process is happening whilst we're also developing the cell production process. And so as you develop the component production process, you also develop the cell production process. So you can do 5, 6, and 7, 8 in parallel. And then once you've got to kind of 6 and 8, you're then able to come back and do full commercialization. And that enables you to basically say you've got a fully working pilot plant, and that would enable us to then go to a large commercialization plant in Australia and around the world, because all we'd need would be our natural gas and the materials to supply that, which is basically aluminium, but in different forms. So what we're working with Rio is to go through 3, 4 and get to 4, and then edge into 5, 6, and 7, 8 and then see where we get to. We should be probably getting into a pilot plant for the cell, for the pouch cell. That's one objective we could meet. But there are other ways of making pouch cells, and we could work with a contractor who can do this as well. So we'll, and that there's benefits. That can be faster, but then sometimes it's sometimes better to learn the mistakes yourself and kind of stumble through those and then build the pilot plant yourself. So 5, 6, 7, 8 is what we plan to do in the next year to 3 years as we program and we build our pilot plant or contract it out. Now, what that will enable us to do is to show that we've got a purpose-built graphene plant and a purpose-built pilot plant, hopefully sitting next to each other in our headquarters here in Richland in Australia. And then we can walk people around and show how the graphene is produced from natural gas, how then it's then made into the aluminium-ion battery, which is then providing people, customers with thousands of cells, pouch cells, to say every week. That's where we want to aim. If we can get there with Rio, that's a success case. There are all alternatives that actually will be we'll be able to get there without necessarily just exactly that. We can probably swing some other things through together, but that would be a true success case where we've got thousands of cells coming out and we've enabled Rio with their battery pack, and then we've got cells to share for others to test as well.
Is your battery technology, is it potentially like a replacement for the lithium ion batteries and the variants thereof that we have now, or is it going to be more of a specialized one in these extreme environments with high power discharge and that? Because right now there are different types of batteries for different uses. Could this be a bit of a universal battery, or will it be kind of a niche targeted battery?
Yeah, I think I was on an ABC radio show and they said someone said phones to drones, and it can do trucks, vehicles, house batteries, grid batteries. It could be a universal battery, but where we'll find ourselves going is where lithium batteries have real trouble right now. And lithium batteries are here to stay. They've got a lot of problems, but they're here to stay and they're scaled, and they'll keep growing, and because it is scaled, they might adapt to a new slightly different materials, but that's well and truly away. And even today, you've got old battery technologies that are still out there that were replaced by lithium. So it shows you that these genuinely technologies don't get removed completely. So we'll go where we believe we'll go where lithium batteries aren't prevailing, and that's in really high power discharge and really rugged terrain where the work that the lithium battery's got to do is just too high intense, and that's really in a diesel engine type domain. We've got a large, obviously Rio is all about diesel engine replacement, and we've got a large number of companies who are in that space in NDA who are looking to replace their diesel engines with batteries. And then there's the grid space, which I think will also provide us with some ample opportunity, being a peaking like station battery, which we can come in and provide energy fast to meet the demand of the grid, which obviously is going to have more fluctuating power supply in the future with renewables. So that's another space. Then vertical takeoff and landing. There's something like 700 vertical takeoff and landing companies around the world, startups basically. And they won't all make it, but even if 10% of that's an enormous number of companies who want to get there, and they all need batteries, and lithium battery really has trouble doing that. Just a high power demand is a bit too intense for the way the lithium chemistry works. So yeah, I think that's where we're finding our niche, and where we found it with Rio, where we'll continue to find it. Sure, it could replace the lithium battery, but in terms of an EV, but it won't really serve all of the advantages out, and probably best to have a lithium battery in there for now. And then we'll see how we grow into the other sectors as we've hopefully met demand, because the diesel engine battery demand is just massive, and there's very little to no competition apart from potentially hydrogen. So it is going to be a pretty intense ride, just even focusing on diesel engine battery. I mean, diesel is $1 trillion market a year. I know that from Shell. So this is a scale-up process of where we're at right now with respect to the battery in terms of cell making. So we've made thousands of coin cells, and that's kind of proven up the science. Now we're on this single layer pouch, which we announced we were making, and we've got good progress there. And the science is progressing from the coin cell to the single layer and 5-layer pouch cell, and that's going quite well. In fact, we've found it's easier in some cases to get the 5-layer to work more than the single layer, because you've got 5 layers working rather than just 1 layer. And that's really quite good. We're very happy with that. It's enabling us to project to where we can start to get to about 25 layer, which will enable, that's when we have a successful pouch cell. So 25 layer will be something that we'll be able to provide for customers to test. There's very few companies that can actually test coin cells. Companies tend to just say, well, I'll test a pouch. I'll test a pouch once you've got one. And then actually then there's a lot more that can actually just test the battery pack. So they can't actually test a single cell. There's lots and lots of companies who are waiting for a full battery pack. So the full actual pack that the customer will get, they can only test that. And we've kind of understood that through just hundreds of conversations with customers around the world and try to understand how we fit into the scheme of things. This cell that you can see here, that the 5-layer, we make them probably close to 30 to 50 a week now. And what that does is enable us to test different types of materials, different types of charging, storage rates. And it enables us to get a much bigger picture of the different materials we're trying to test at scale. We get new materials probably coming in once a week, I'd imagine, from different suppliers around the world, trying to give us something that, of course, if they can supply us some material like the thin film separator or the cathode that substrate, where we're putting our coating on, if they can supply that and get that, well, obviously then they'll grow with us. But to really get to the 25-layer pouch, we need this thing called this semi-automatic stacker, which is the picture down there. It's just it's a robot. It's got 2 robots actually, which stacks the product and the cathode and the anode directly on top of each other with effectively no error or minimal error. And that enables us to get to 25 layer, because when you're manually putting these together, if you're sitting with even the smallest error, you can actually then get crossover in the cathode and anode touch, and then you short the battery. So we're kind of going to the end of what a manual laboratory scientist can do. So we had the semi-automatic stacker to arrived, and we're basically commissioning that, and we're putting that into play, which will enable us to do the 25-layer pouch. And once we've had that going for a short period of time, we think we'll be able to then say, this is where we're sitting with our pouch, and then having to be able to test them and do more rigorous, what effectively is A/B testing. There's a lot of A/B testing in the battery world, where you test something and you change one thing and you go and test and see the difference. There's a lot of theory that goes into this, but then you use the theory to then go into A/B testing. And so, but we don't just have 1 or 2 variables. Yeah, we have billions. So how do you actually go from 5-layer to 25-layer and successfully do that? Well, that's what we have our scientists for, and we go through what's called a design of experiment, and we run that through. And then once we've got that, we then build or get a contractor to build for us the sample A-type, just to scale up through that process. And then once we've done that, then hopefully we're sitting with a scale factory kind of next step. Now onto some last other items. before we can go on to your questions, Martin. So, yeah, we obviously got an ACUS approval, which is a full and final approval for all our products to produce them in Australia as well as sell them. And this generally meets a lot of country regulatory approvals around the world. Australia is pretty rigorous nanomaterial regulations, which, you know, is similar to American, European, Canadian. And so when we meet this, we do meet a lot of others, but there are some things we still need to go through paperwork for, including for America. And so that's what we're doing for America. We've also got full regulatory approval for a development of our battery plant at our headquarters in Richlands in Queensland as well, which is very exciting. Now we've got some close to 5,000 square meters and it's surprising how it does fill up. So Unit 4 is where we have our graphene plant being built, and that's also where our thermal XR and G lubricant blending plants are as well. Unit 5 is where our head office is, and it's where our battery development center is. And also we have a thermal XR demonstration center, which will show customers how thermal XR works. Now we've just signed up a lease for Unit 6, which is enabling us to have coding laboratory QA/QC, and then also having more office space because we're pretty much full. That enables us to have a pretty strong amount of space and laboratory space, warehouse space to be able to do what we need to do. That pretty much completes our ability to do what we're doing in this phase. Obviously, when you start building a large battery plant, it won't be here, it'll be in another site around the world, wherever it need to be. But that, you know, where we are now is we've got pretty much all the space we need to do what we have to. We're obviously working with, and we've announced, we're working with a search firm to look to replace our CFO. So our CFO joined us a year ago, and Frederick is moving on after coming in and heavily helping us move ourselves into a fully listed finance function. We really thank him for all his work. He actually, we brought him back from retirement, so quite young, retired, and so he came in to help us get where we are, and we're really happy for him to move on to what he wants to do, which we're very sad to see him go. Now, one last slide. So, you know, where are we at with our financial capability? Because we obviously need to be able to stand on our own 2 feet eventually. We're developing 4 brand new technologies that the world has not seen, and we're developing that all at the same time. We're developing, we're producing, we're selling all at the same time. So we're a multifaceted business, and if you add all of the components of our business, there are multiple businesses out there you could actually probably put together and say that is what GMG is in entirety. But we're maturing our sales and marketing team, that's for sure, with our distributors coming on board, with North America coming in shortly with our distributors for thermal XR. We're NDAs with large global companies. We're targeting these large sales for TXR as well, with now that we've proven that we can shift heat faster. Obviously, we're working with Rio Tinto on a battery with $6 million coming in. We typically see about a $1.5 million from R&D tax rebate, which is cash back into our account in September. And we've got a number of grants and incentives that we're talking to people about. And then, of course, we've got cash in hand, about $8.5 million at the end of March. Maybe over to you, Martin.
Thank you very much, Craig. That was excellent. We've got let's call it a boatload of questions here. With your graphene production, you're not selling sort of bulk graphene. Why not? Why not do that initially, generate some cash flow? You seem to have high quality graphene where you can modify the characteristics readily.
Yeah, it's a good question. I got that asked a few times this week for people walking around seeing our plants. We started off in 2016 and 2017, which we built a plant, and we went through 2019 making graphene and talking to and doing experiments for about 200 different companies, customers, applications around the world. And we realized graphene is really difficult to work with. And it does amazing things, but unless you know how to work with it, it doesn't do those amazing things. So you really got to treat it, and it's like a tiger. You've got to get on the back of it and make sure it doesn't bite you. It does bite you a lot if you don't know what you're doing. So what we developed was a capacity to do those mixing and making those products. And then we'd hand it to the customer and say, wait a minute, we're doing all the work and we're giving it to people. And then they still have trouble kind of getting to the end of it and understanding it. And so that's why we went into the integration. You got to go in this space, you really got to get into the vertical integration to be able to get to a space that you can get to a product which you can sell easily. So graphene is I would suggest we're probably 100 or so companies around the world could have handled our powder at the time. It was that few after talking, and even then they would have trouble. Our graphene is so light and fluffy, it doesn't even obey gravity. Sometimes it appears to anyway. But now we're going to 3 products that pretty much any company in the world can buy. So it's opened up our opportunity to, and people just use it. They can buy it and use it. They don't need to know about nanotechnology. We've created a platform for our technology, which is the graphene. And if you look at the last nanomaterial that changed the world, which is silicon, and the largest nanomaterial producer in the world is Intel. And no one really talks about Intel. How do they make their silicon? Everyone talks about their chips. Well, that's where we need GMG to be. Well, what do we know about GMG's process? Well, I don't really care. Their products are amazing, and that's where we're going.
All right. I want to lastly circle back to the lubricants side of it before we go to the audience questions. The lubricants, in a way, seems like it would be the easiest market to penetrate in a way. The benefits, and I guess just the benefits of your lubricant, does it actually like lower coefficient of friction, I guess? So the engines or there's less friction, so less heat generated and so forth. And as well, does it provide longer life? So you have to change the lubricants less frequently? Are those the 2 main benefits?
What we see is we reduce the wear, and we tend to build, the graphene tends to fill into the metal deposits, which enables us to reduce the friction and also reduce friction just because of the graphene is obviously graphite, which is a big lubricant of its day. And we're obviously smaller, about 1,000 times smaller. But the one of the main things, and this is probably more difficult to understand, is it actually gets in between the pistons and the sleeves of the pistons, especially diesel engines. And when you do really high load work and really high torque work for engines, there's obviously a lot more friction in those piston sleeves. And what we're finding is we think that we're lubricating those where typically the oil doesn't go very well. It tends to not lubricate much. And so we're seeing some really large fuel reductions in customers' fuel construction site type activities. Now, what that means is we've probably got some kind of breakthrough fuel testing, a fuel reduction additive, but we need to fully test that. So again, customers saying they're getting large percentage reductions, like 2-digit percentage reductions in fuel because of our graphene oil additive. But we need to go test that. So what we're doing right now is we have our own engine. We've isolated all of the things that could go wrong in terms of weather and other things that could change the type of fuel energy ratio that are burning for the engine. And now we're going through our own trials with the University of Queensland, reviewing that data. So that's something that we've worked out, that we tend to break tests. We tend to do things that the test wasn't designed to meet or understand or test, and as a result, we tend to get these bizarre testing results. So you've got to find a way to break through that, and that's what we're doing now with our own engine. Because you can do all 4-bore wear testing and lubrication, friction testing, and you get some of the understanding of what the graphene oil can do. But really what you need to do is just put it in an engine and do fuel monitoring. And that's what we're doing.
All right. And going to customers, and you've got several distributors globally selling the lubricants. Is it a hard sell? Do people say, no, that sounds like garbage? Or it could maybe do something bad with the warranty on the engine? Or
Yeah.
what kind of, because it seems in a sense you get these energy savings and wear reductions. That's an easy sell. Is it just a skeptical market that doesn't believe it yet?
Well, I was a marketing manager for Shell for industrial lubes for Oceania, and so you've got to be careful. This industry's seen a lot of snake oil salesmen. That's literally where the name's from, and so you've got to take it step by step with data, and you've got to go through people who are willing to try new things. Thought leaders and early adopters. You work through those guys, and then you should be able to make some wins, and that's what we are doing. But the case is we've got to try to get more data, more specific data on really controlled tests, which will show categorically what the energy fuel savings are. And then once we have them, we can then go forward and optimize around that as well. And then that should enable us to get more data. What we've done with Thermal XR is build up a program that's been generally about 2 years worth of work of technical testing, and there'd be some easily over 10 different types of tests that we've been doing, and over time optimizing those tests to get where we are. And we need to do that for the lubricants, but we think it'll be faster.
All right. And now we're going to go to the audience questions. There's a lot, and we'll try to get through as many of them as we can. Firstly, what is the status of the battery patent?
Yes, you can see the pouch cell where we can, in the photos before, we're doing 5-layer pouches right now. And then hopefully shortly we'll be doing 25-layer pouches, and then that will be our first pouch that will look similar to that. And that's what we can actually send out for testing.
All right. I think you touched on this with your bulk graphene production, but I'll ask a question for any additional nuance. Why is GNG not expanding the graphene market? I'm guessing selling bulk. There seems to be a world shortage.
Yeah, I think there's, when you look at the graphene applications, that you've got to optimize the graphene for the end outcome. And if you're in composites, then there's certain graphene for that. We're in a different market. We're in energy savings and lubricants and coatings and then batteries. I think for now, we're working on our end products because of what we were saying before. And, if there are companies who desperately want our graphene, well, and we can make it work, we will. But right now, we're really focusing on our products.
Have you contemplated doing like a strategic partnership, maybe working with another material science company that is good at strengthening things and sort of licensing it to them, let them do the R&D and the heavy lifting on that to sort of expand your market potential with a partner?
We've done an enormous amount of testing on our graphene for concentrates for strengthening, but composites, but it takes a lot of work to get there, even with a partner. And they'll be wanting to access to a plant and understand how it works and optimize the material, the process. And so even that is not light touch. Anything in nanomaterials is heavy touch.
Gotcha. All right. Are you aware of any competition to Thermal XR? If so, how does it compare as a product, pricing, adoption?
Don't really have a thermal heat transfer coating out there like ours that we've seen. We've certainly got coatings for HVAC, and typically they insulate and they remove energy or waste energy, but they're obviously for corrosion resistance. So no, we haven't seen anything out there. In terms of pricing, we typically price about a 1 to 2 year payback for the energy savings for a customer. Whereas solar is about 8 years. So the end application is quite economic when they can get their payback within 1 to 2 years. Typically that works. And as I said, solar started about there, but now solar power cells are sitting at around 8 years. So over time, they've just pushed that price up.
Gotcha. We have a person here who's working on some disruptive air conditioning technology and wants a contact person at GMG. How would one go about?
Yeah, our website's got our phone contact details, probably the best. Their contact form is best for that. Thanks. Yeah.
All right. Do you have to remove trace gases from the methane to get the high quality graphene?
We spent years trying to work out whether we had to get rid of the trace gases, which are generally in Queensland, it's 98% methane and 2% nitrogen, and there's a tiny bit of other things in there, a bit of helium, a bit of argon. So no, we don't have to do that. We're targeting the carbon atoms, and that's what our plasma gets.
All right. Air conditioners are rated, at least in North America, with a SEER number, SEER, indicating its efficiency. It would appear that Thermal XR leapfrogs the existing technology. Have you submitted Thermal XR treated air conditionings for a re-rating? Is that in the future?
Yeah, it's a good question. So not yet. We've got green certificates that could come from this as well, because we're obviously saving energy. We've got technology that can, instead of putting solar cell, you could put our technology on. So there are a number of government regulations that would support us. What we've found is we need scale before government regs will support us. So we need to get scale, and at least anywhere in Australia. So no, I think we haven't pushed that far. We think we need to get some OEMs through the door, probably push that into the next stage. But thanks for the tip.
Right. My understanding is that the graphene aluminum battery cells are half the voltage of a typical battery. Is this correct? And how will that be managed?
Sure. So our voltage typically goes from around 2 volts, 2.5 volts. We can go high, about 2.7, down to around half a volt, because we can fully drain our battery, which enables us to get to a nominal voltage around 2 volts. Now that means most of the time it sits at 2 volts. Of course, it's discharge. So if you're talking about a lithium-ion battery, typically, its nominal voltage is around 3.4, around there, 3.1. And what that means is our batteries need to be able to sit next to each other to be able to get to that voltage, so we can get to 4 volts if you put 2 hours back to back. Now, all our applications, we're working on 800 volts. All the big trucks are sitting at 1800 volts. So lithium batteries need to be added together to get to 1800 volts. We also need to add together to get to 1800 volts. We are working on other electrolytes. We can get to 4 volts, and they're in our laboratory, so we can get up to 4 volts. But we need overall outcome to be what we want, not just the volts. We need capacity, longevity, and fast charging, all of that as well. So there's a number of opportunities. We just replace the electrolyte. We can get a different voltage. We've done that. We've done that now so we've got 3 main electrolytes on the go. Yeah, but in terms of application, there is really no difference, because lithium batteries need to be added together to get to where we need to be, and just like we will be as well.
All right. With so much potential in the battery market, why doesn't GMG secure a large partner to advance development and production?
Yeah, it's a good question. We basically need to get to a pouch cell factory, that small pilot plant I was talking about before I think people will definitely take us seriously. And I think that's when, I might be wrong, but I think that's when people will put their hand up and say, "Oh, right, you've done it. You've got an operating graphene plant, you've got an operating pilot plant. Wow, okay, how do we work together?" But then it'll probably be too late for most, because we would have had our partners already by then. But yeah, I think that's what a lot of people are waiting for, because that's when it's proven. But we're well on our way.
Because your expertise is in at this stage of the development. When it goes to factory global scale, you've got some from your big petrochemical background, but that's where maybe partnering with a big battery company who knows how to scale to millions or billions of units would they'd add their value at that point.
They could, but just to be clear, there's about 40 suppliers of these equipment around the world, of lithium battery manufacturing systems. So we're getting these off the shelf. So all that development work is done by others. We can access that for relatively low cost. We have just joined us to our board is the previous CTO of CATL, which is the largest battery manufacturer in the world. And he's just joined us only a year ago after leaving CATL. And so he's built more factories than anybody else to make batteries. And in fact, I've just seen he's just joined me on my computer on the other side while you're waiting for me in the other room. Yeah, so we certainly have the ability to attract people who can help us scale. We've got this amazing, what I can say, technology that has attracted some world leaders who want to come and work with us. And so I don't necessarily know if we need to have a world-scale partner. We'll certainly bring people and customers and technology suppliers, and we've got companies like Bosch who we're working with to help us scale as well in the factory. And so to the nth degree, how and when we get there, we will, we'll put all that together. A big partner would help, but it also brings lots of other things, including, having to manage their percentage and how they want to work and all the rest with us. So I've certainly done a lot of work with JVs in my past career. But yeah, we're not excluding them.
All right. Have you explored the possibility of using thermal XR as a coating for high voltage transmission cables to manage temperature?
Yeah, I think this might be the last question, I think, Martin. But yeah, I think we've certainly got some opportunity there. The aluminium core that the power lines transmit generally are restricted by heat, and same with copper. So if we can spray them with our thermal XR, we should be able to remove the heat, which then should be able to get to have a higher transmission of power. That would make sense. We haven't done the work. We've certainly done the heat transfer work, but from what I know, we've got certainly a good opportunity there to increase power transmission and reduce resistance.
All right. It sounds like you have to go. Just one final wrap-up questions. What are the key milestones, let's say, through the back half of the year that investors should be keeping their eyes open on? Yeah,
well, certainly we've got to come out with a pouch cell tested results, and that'll take some time, but we hope to do it this year. Then we also want to be able to show the TXR progress. So moving into an American distributorship, which is something we've got to close out, and hopefully very, very soon. And then, provide some revenue with both that and other distributors, plus also large projects, which we aim to do to reduce people's energy consumption, large companies, specifically in the LNG space. So there are certainly areas that we believe we can do this year.
All right, Craig, thank you very much. Very informative. Congratulations on all the progress you guys have made. And thank the audience for participating and lots of questions. We didn't even get through half of the questions here. So thanks everyone for your patience and the great questions. And Craig, thanks for sharing a lot of information.
Thanks everybody. And thanks, Martin. See you again. Cheers.